Alright guys, so this is the updated video for the Trig Identities. I'm just going to kind of fast forward to where I believe that the sound stopped. So I believe we got through this whole example together, and I think maybe somewhere around here on this page is where the volume cut out. So what we have here, we had, they said that tangent was -8, that the sine was positive, and we needed to find our sine and cosine values. So when you're doing this problem, so this one came from our Pythagorean identities. On here, we know that tangent squared of theta plus 1, that equals secant squared theta. So if we can rewrite it, then we can solve it through. And you have down here that the secant, as you get it by itself, you square root, and we get that positive and negative option for our cosine. So what we would do from here, because you know that the cosine should be negative, and the reason that we know that, let me get the pen going. So they told us that our tangent of theta was -8. We know that tangent equals the sine over cosine. So if our tangent is negative and our sine was positive, that would mean that our cosine would have to be negative. So you go back to what you know, how tangent can be rewritten. The information that they gave us was that sine was greater than 0. So that means that if that's positive, our cosine must be negative. So our specific cosine value here would just be, well, you can cross multiply and divide. So when you would get that, you can just flip it over really, and you have the 1 over, that's negative, equals cosine of theta. And then from there you would have to rationalize. So you would multiply both the top and the bottom by the square root of 65. So you would go through and you would have over square root of 65 times itself, which becomes just 65. So that's our cosine value. So once you get your cosine value and now you're trying to find your sine value, we can use what we know about tangent. We can go back and we know that tangent of theta equals sine theta over cosine. We know that tangent was -8. And we know that our cosine was -√65 divided by 65. So we're just trying to isolate sine. Right now it's being divided by the square root of negative square root of 65 over 65. So we'll multiply both sides by -√65 over 65. So you don't have to flip it because we're not trying to just simplify the one side. We're trying to actually get it to cancel. So just think it was being divided by this fraction, so we're going to multiply by this fraction over 65. So if you could simplify from here, you would. Not necessarily going to happen between 8 and 65. So your answer is actually going to be 8√65 over 65. So that's what our sine value is going to be. So here's your sine. And then your cosine we had already had was negative square root of 65 over 65. Alright, so let's go to the next page. So on this next page, we have two different sets of identities. So our first set was about our cofunctions, and our second set was about when they're odd or even. So it's kind of like a combination of all of these. When you're looking at what's given to you, they're giving you cotangent in terms of theta minus pi over 2. So if you look at your cofunction identities, we can manipulate what we have to appear similar to our cofunction. So if you look at what I have on this side over here, this cotangent, I factored out a -1. So the reason that the -1 was factored out is so that we were left with a pi over 2 minus theta. Looks just like up here. These are the two that we're going to be using. So you have your pi over 2 minus theta, the negative. When the negative's on the inside of cotangent, it can be brought to the front. So that was the use of this identity in here. If the negative's on the inside, it can be brought to the front. we're using our cofunction to rewrite this as just tangent of theta. And we know tangent of theta was 1.28. So our whole response, our answer would be negative 1.28. All right, let's get this a little bit smaller. Okay, so in this problem, you were trying to simplify. Now this is what you have. I posted an additional video on, as well as the worksheet to work on a problem similar to this. So you have to think about ways that you can rewrite what was given to you. Okay, so looking for the identities that would include either the specific way that that function's written, or if it's multiplied against something specific. So we have our first one where we can rewrite cosecant. So cosecant is 1 over sine. Then we have secant. Secant's 1 over cosine. We can also rewrite cotangent. Cotangent's cosine over sine. So those are just ways that we could rewrite those three functions. So when you do rewrite them, now we have our first fraction minus our second. So our steps here would be, okay, so I need to combine these. They need to have common denominators. I need to multiply this one by cosine over cosine. When you do that, you would get cosine squared over sine cosine. So that means that you could do 1 minus cosine squared over sine cosine. So 1 minus cosine squared, so that comes back to this Pythagorean identity. Okay, so sine squared plus cosine squared equals 1. So you can use that to rewrite that as sine squared. When you do, you end up with sine squared over sine times cosine. So you can eliminate the sine squared over sine, just becomes sine on top, just cosine on the bottom, and we know that sine over cosine is tangent. So if you look at the video that I posted about simplifying the trig identities, you'll see that they're really more about finding ways to rewrite and to write less of the trig functions. So how we broke this down, instead of 3, now our final answer is just tangent. Okay, here's another problem that's similar again, and you can also see more of this in the latest video before this one. So we have our sine squared cosine, and then minus sine of pi over 2 minus x. So you can use the cofunction identity. This is already set up where it's pi over 2 minus your variable. So the cofunction of this would be cosine. So you have, if you look here, both of your terms have a cosine in common. So this was what I was talking about when I said if you can factor something out, factor it out. So then the issue is here, we factored out just our cosine, and you end up with sine squared x minus 1. So that's not quite equivalent to this over here. If this was sine squared x plus 1, sorry, erase that. Not that if it was sine squared x plus 1, but the actual sign, S-I-G-N, of your signs need to change. So you need to take out your negative 1. Then you have it rewritten the way that it needs to be. And then from there you have what you can rewrite. So you have 1 minus sine squared x becomes cosine squared. With this, you can just combine into 1. So you would add your exponents. There's really a 1 here. There's 2, so you have cosine cubed, negative cosine cubed. So go back to the other video where it shows you just the ideas to rewrite, to simplify, and to kind of like pare it down and make it the least amount of terms possible.